a plus 2b. So you had to take into account that we knew a to b of f of x dx was equal to a plus 2b. And then they said, okay, what's the integral from a to b of f of x plus 3 dx? So what you had to do was treat this like our rules, where it says, okay, a to b of f of x dx plus the integral from a to b of 3 dx are the same thing. Well, we knew this answer, so it was a plus 2b. And then you had to antiderive this answer. So that meant that this became 3x from b to a. So you got 3b minus 3a by plugging into your rules. And then you had to combine like terms. So a and negative 3a gave you negative 2a. 2b and 3b gave you 5b, which was answer choice D. Okay. For 2, it said blah, 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 is a Riemann sum approximation. Well, I don't feel like reading all that. There's lots of square roots in there.
So each one is
What? So what you had to do was figure out, okay, what are those going between? So if you start at the square root of 1/20th and you end at the square root of 20 over 20, then it's kind of like a right Riemann sum from 0 to 1. And it would be the square root. I'm just not realizing.
Why?
Yeah.
Where?
The 1 over. It's the width.
This book.
The 1 over 20th is the width.
This book has all the answers. I just didn't have them.
Oh, 1 over 20th is the width. So remember, Riemann sum is area equals length times height. So that 1 over 20 is like all the lengths, and then everything in the parentheses are all the heights. So the first height is 1/20th. So every height after that is what's happening as you move along this. So here's the first one, here's the second one, here's the third one. We had 20 of them. And it ended at 1. So the Riemann sum was a right Riemann sum of the square root function with widths of 20, because it's b minus a all over n. So the b minus a had to equal 1 and the n had to equal 20. That's how you kind of transformed it back. It's hard to explain it any other way. Okay, and then 3, what are all values for k for which the integral from 2 to k of x squared dx equals 0? So what did we think? How do you get an integral to equal 0? Okay, it's even easier than that.
Same bounds.
Upper and lower bounds have to match.
Did you miss that one? Yeah.
Yes.
I missed that one too, but I said it's
I didn't realize that. That's
the only one I couldn't
What
What are you laughing at, Sam?
Good
for you!
If you antiderive it, it becomes cubed, and a negative cube will be negative.
I am a rule.
What?
You see what I'm saying? You were thinking the fact that it's symmetric, but it doesn't work because the antiderivative is cubic. Yes. I had 5.5 out of 6.
What's different golden row?
did not realize it was Apple TV that easy.
But, so that's like the, you know what I mean? That's why we kind of do these.
Yeah.
Like, because it's that exposure. And I just wanted to be able to, like, give you the feedback that we did it up last time to go over them.
Oh my God. Be careful. Bottom. You want to like hurt that baby,
All right. So the rest of today is rather easy because all we're doing is what we've been doing, except for we're not plugging in anymore. So tomorrow, when you do everything we do today, which this is a good review for you for tomorrow, you plug in the bounds. Today, since there's no bounds, we don't plug anything in. We just add the arbitrary C. So tomorrow, I think, is actually a little bit more challenging than today. So I gave you the 6 trig ones again, just to help remind you to review them and have them in front of you. We already did this definition, but I want to give it to you again. It says if f is an antiderivative of lowercase f on an interval I, then the most general antiderivative of f on I is capital F of x plus c, where c is an arbitrary constant.
I think that's okay. I would have done caramel though. Like caramel, you know what I mean? Like one of those small like shrinkle. I don't know. Something like that. Something shrinkle is a word. Shrinkles is like the bread. Shrinkles bread. Next. Really? Is that what it is? Yeah.
All right. If you want to find the most general antiderivative for the following function, essentially what we are doing is finding the family of functions. So what you want to do is you want to antiderive lowercase f of x. So what we are doing is we're basically saying, okay, I want you to find the antiderivative of f of x dx. So use your power rule. Add 1, divide by it. The only thing we're doing now is because we don't have an upper and a lower bounds, we add the arbitrary c. So no numbers, add c. Letter B. Like I said, it is less than a piece, and it helps you for tomorrow, because tomorrow you don't put the C, you'll have an upper and lower bounds, and you plug in your numbers. But it's still a review for tomorrow, because we're still going over it. 12 divided by 3 is 4, so you get 4x cubed plus 3x squared minus 4x plus c. We do like to clean it up, though, so maybe don't use your fractions.
I'll be at minus half a point.
If you don't put the plus c's, it's a minus 1.
Oh, wow. So that made also there. That's not perfect.
So again, power rule says we add 1. So you get negative 2, and you divide by your new exponent. So this is really like negative 1 over 2x squared plus c. That 2 is part of the denominator. I think sometimes we try to bring it up. Okay, letter D. Antiderivative of sine is? Antiderivative of cosine. Antiderivative of secant tan.
Page. Page flip. Go down, go down.
And secant squared. So nothing terrible. Okay, for your square root, I would treat it like an exponent. So I would rewrite that so that instead of being the square root, it was x to the 1/2. So you get the integral of x to the 1/2 dx. So again, power rule says add 1, divide by your new exponent. And don't forget your arbitrary c. So you get x to the 3/2. If we're dividing by a fraction, it just flips. So that 1 over 3/2 would become 2/3. An arbitrary c. What rule don't we have yet for letter I? So what we have to do is rewrite this so that the x cubed goes with each term. So what you're going to do is say, okay, 2600 x to the negative 3 plus 2x over x cubed. Well, that top x would cancel, so you get x squared. So you get plus 2x to the negative 2. Cubic over cubic is going to cancel out completely, so you get 0.001. Now you want to find your antiderivative of that.
Oh, ours has a square.
On which one?
For the 0.00.
This?
Yes.
So that means we have an x to the negative 1. Okay. Well, and it changes it too because the x to the negative 1 is going to actually change what type of function that is.
Okay.
Because if you add your 0, and if you add your 1, you get 0. So it makes this last piece by me making that a square a natural log instead of being an easy one.
Well, that's good.
So, which is probably why I changed it up here. I just missed it on my notes. So, add your 1 back. So you get 2600 x to the negative 2 all over negative 2 plus 2x to the negative 1 all over negative 1. And so what I was getting at here is this is the example of the natural log, because it's like 1 over x, where this is your constant out in front. So this becomes plus 0.001 natural log of x. And do not forget your arbitrary c. We could clean it up. So 2,600 divided by negative 2. Okay, what do we think about e to the x? Yeah, it's just going to be e to the x plus c, because the derivative of e to the x is e to the x. Page. Okay, and then think about how the k would change. So what I would do is kind of treat it as bringing that 3 out in front of it. So that means that 3 would tag along. So it becomes 3ex. It'll change, but we'll look at that later when the x has a coefficient with it. It's like the natural logs, where you have like your rule where you have to check to see if it's u prime over the natural log of u. Okay, the very, very last part. So what we do in these examples is we're given the derivative, and then we're given what we call an initial condition. So now what we're going to do in example 2 up here, or example 1 rather on your paper, is essentially find what the arbitrary C value is. So that C could have a value if you have conditions. So these might also be called initial conditions. So treat this the same way. You want to find the integral of f prime of x dx, or in this case, the integral of x square root x dx. And how could we rewrite that to be something we know how to find a derivative of? We don't have a product rule, right? So what could we do? What is the square root of x? Yep, and what's the rule if you're multiplying like bases and
You add that.
yeah. So now we have an antiderivative we can't find. So add 1, divide by your exponent, include your c. Remember that this represents f of x. In an arbitrary state. If I want to know this, what I'm going to do is I'm going to replace the 1 for the x's and the 2 for the x plus c. So you get 2/5, 1 to the 5/2 plus c equals 2. And then you solve for c. So 1 to any power is 1. 1 times 2/5 is 2/5. So subtract 2/5 away from 2. And you get c equals 1 to the 3/5 as a mixed number. Or you could write it as 8/5. So that means for this, f of x is 2/5 x to the 5/2 plus 8/5. Remember that the derivative of any constant is 0, so then when you derived it, you just get the 3/2. We'll do the next